Okay, so that's what we're going to talk about here. You want me to hit one of these things here? There we go. So a polynomial, poly means many and nomial means terms. So it's kind of hard to define them, but I'll just kind of give you some examples of some polynomials. And some that are not. So these ones all are polynomials. Okay, separately they are. So anytime we have a term, so this is a term here, and this is a term, all right? So if we have some sort of arrangement of terms, that's going to be a polynomial. However, you can't have a variable in the bottom. So if it was like this, then this is not, because the variable is in the bottom. Okay? That is not a polynomial. That's something different. It's possible to just have one term. So if we just had 7, that would be a polynomial because it's just one number, a constant. All right, so that's possible. There's a couple different ways of naming these. They're named by their terms. This one's called a binomial because it has 2 terms. This one's a trinomial because it has 3. Okay. And then after that, this one is another binomial. They usually go by different types of names and classifications. Here, let me write this down below here. Try to keep that there for you. The other way to classify them is by the degree of the polynomial. And the degree is the highest or largest power or exponent. Okay? So, the degree of these, all right? So the first one, this one is a first degree polynomial because the power on the variable is 1. So that would just simply be a first degree, or 1 first degree. All right. The second one, the highest power on the variable is a 2. So that would be a second degree. So it has a degree of 2, or we would call it a second degree polynomial. The next one is 3, so that's a third degree polynomial. And the last one is 5, that would be a fifth degree polynomial. All right? So the higher you go in mathematics, then the more you're going to see them called by their degree more than the other words. But pretty much in this class, Like when we do chapter 6, we're going to refer to them as binomials and trinomials. Okay. I'm not going to ask you on a test or a quiz what's the name of this polynomial. I'm not interested in you knowing that. Okay. Not as far as the test goes. All right. So that's what polynomials are. Okay. What they want us to be able to do, as I said, was do some operations on them. So we're going to do some addition and subtraction, which you've kind of already done. I'm just going to put add and put simplify by it because that's what it's going to be called on your test. I'm going to just say simplify. All right. So let me give you an example here. And I'm going to put parentheses around the polynomials because that's kind of what they do in the book. Okay, so we're just going to add these polynomials. When you add or subtract a polynomial, you do that to the like terms only. So the key idea here is like terms. So I'm going to combine those like terms. So like here I have a 3 and a 7, and here I have an 8 and a 6. So 3 plus 7, I'm going to add that up. That gives me a 10x. All right, then we have an 8. I probably sort of circled this 8 so that you know that it's positive. So I have a positive 8 and a negative 6, or a minus 6, however you want to think of it. We're going to combine those, get us a 2. And that's done, because you cannot combine unlike terms. Can't do that. And that's how you add them. It's pretty straightforward. You should have did some of that, I think, in Math 60. But at that time, you were just messing around with expressions. Okay, now we're doing polynomials, but it's not a whole lot different. Okay, so again here we're looking for the like terms. So I'm just going to go here and kind of combine those. I'm going to try to do them in different colors so you can see the difference here. So we have 4x squared plus 2x squared. So I'm going to combine that, get 6x squared. Then I have the 10x plus a negative 4x or a minus 4x, however you want to treat it. So that's going to give you another 6x. I have a minus 3 and negative 3 plus a 1. And it's done. Notice that I started with the higher, I took the high power ones first. And I wrote that first. That's probably a good idea because in chapter 6 you're going to want to do that. Okay, so when you can, that's called writing it in decreasing order. So because you're writing it and the degrees are going down. So it started with 2, 6x squared plus 6x, exponent is 1, minus 2. Doesn't have a degree because there's no x there. All right. So you kind of want to start with that highest power first. Some of them are going to be kind of where it's going to be hard to discern what the power is, and that's okay. Just write them out then if you can't figure that part. I'm looking to see if there's any other ones. Let me try one of these, I guess. Some of them write them in Y's. So again, we'll find those like terms, okay? So I have a y cubed. Are there any y cubes in the next one? Any y cubes in the next one? No. Okay, so that's done. I can't do anything more with that. All right, look at the y squareds. We have a y squared here. We have a 3y squared here. What is that going to give us? 2y squared. Good. Okay, then we have a 5y here. Do I have any y's in the other one? Nope. So I just drop that down to there. Okay, and then I finish it. I have a positive 1 and a negative 2. What is that going to give us? Negative 1. Very good. Okay, so that's all you can do. You can't combine terms like that. They have to be like. Okay, and none of those terms are like. They don't have the same powers, so we can't combine them. So that's done.
Would you ever have a like terms within a
Polynomial?
within a what?
Within a polynomial?
Yeah. Like where you'd want to add them? No.
Don't think so. So, subtracting, not a whole lot of difference. It's the same thing. It's just now you're subtracting. Okay, so say we have one like this. So now we're going to subtract. All right. So you got to decide what makes this work for you. Okay, because I just want you to get the right answer. Everybody's going to be a little different. Think things a little bit differently. So when we do these ones, you just kind of have to make up your own mind how you want to attempt it. What I do, okay, is first of all I take this like term here. Okay, and I go, hey, I got 4y squared minus 2y squared. So I say I'm going to subtract those. So that gives me 2y squareds. Now I have a plus y minus a negative y. So what happens when we have minus a negative? What happens there? Becomes a positive, right? So then I have a plus y plus a y. Now I have 2 y's. Okay, then I have a negative 1 plus 3. So I have a negative 1 minus 3. So what's negative 1 minus 3? Lose 1, lose 3. You've lost how much? 4, yep. So you can think of it that way. Okay? Some might think of it, this way. So I'm just taking the same problem, doing it in a different way. And again, I don't care which way you do it. You got to do the way you think is going to be successful for you. So some people might distribute this minus inside. So that'd be a negative 2y squared plus y minus 3, and then add them. Okay. Either way, you're going to get the same answer. Okay? So I don't care which way you think of it, whether you want to do it this way or whether you want to do it this way. You have to find the way it works for you. All right? But I would, say, when you're doing these problems, slow down a little bit, read them, make sure you understand what they're saying. Okay? So when I'm doing these problems, I'm going to say, like, one of them is x squared minus 5x minus 6x squared minus 4. So I'm going to subtract them. Because what happens is that when we move into multiplication and there's no signs in there, I get a lot of people, they don't see this minus here, and they start multiplying them, and it gets really messy real fast. So be careful, slow down. When you're doing, I know you want to get your work done, but slow down, read it, okay? Same on a test and quiz. Make sure you just take your time, slow down, and read it. So on the very first part of this exercise on 354, they ask you to name the polynomial by calling it a monomial. Monomial means 1, binomial means 2, trinomial means 3, and give the degree. So that's all you got to do on those. And then the rest of the time you're just adding and subtracting them. Okay. I purposely stayed away from 39 through 54 because you hardly ever see any polynomials being added or subtracted in a vertical format. Okay. So that's why I dumped those. You just hardly, I don't think I've ever seen it except in this book. Do you have any questions on what we did there? Do you have any questions on 354? Are there any problems? And I'll give you some time to work on some too, right? Okay, I'm going to do part of section 5-2 and give you a break here. All right, the first part of 5.2 talks about exponents, okay? And what I was going to call the properties of exponents. All right? So, this next thing I'm going to do, I really don't care that you write any of this stuff down. I'll tell you what the properties of exponents is what you want to write down, but the way I'm going to develop it, you don't need to write it down. See, you prefer if you just kind of sat back and watched a little bit. Okay, let's look at this kind of problem here. Let's see, we have this. Okay, x to the third times x to the fourth. Here's what that means. You know what an exponent means, so you know you're going to have repeated multiplication there. Times repeated multiplication there. So how many x's do we have? 7. There's 7. 1, 2, 3, 4, 5, 6, 7. Okay. Repeated multiplication. How many x's do we have? 5. So what's happening here is when we multiply two terms, all right, what do we do with the exponents? You just add them. So the first property of exponent that you should write down goes something like this. All right, so if I have a to the m times a to the n, that's equal to a to the m plus n. All right. Now, again, this is another one of those things where you have to find your way of doing these. And some people, it's been my experience, they want me to show them a property or a law, and they're going to follow that. I got to have a law. I got to have, they think that's what they think mathematics is. There's a bunch of rules and procedures. Give it to me, and I can do it. Okay? So I'm giving you that. Conceptually, this is what's happening here. So sometimes it's easier to think about this. Let's see, I have 3 x's here, I have 4 x's here, so that means I'm going to have 7. Okay? So that's why I wrote it out, so you can see conceptually what's happening. All right? So again, I don't really care which way you do it, but I just want you to be able to get it right. So I'm going to change back to this black again. Do a couple more examples. So if we have x to the 5th times x to the 7th, that's going to be x to what power? Yep. Because all we're doing, what do we do with the exponents? We're just adding them. Okay. How many x's do we have? How many x's do we have right here? And how many here? Gives you how many? See. So again, it depends on how you think of it, right? Okay. Here's one that kind of confuses people a lot. And it's just numbers, not the variables. The numbers actually mess people up. So we got 3 squared times 3 to the 4th. That's going to give us what? How much? So we have one suggestion, 9 to the 6th. Any other ideas?
3 to the 6th.
3 to the 6th. Okay. So let's see which one it is. 3 to the 2nd is 9. And 3 to the 4th, let's see, that's 9. Or 3 times 3 times 3. So 3 times 3 is 9, times 3 is 27, times 3 is 81. And this is going to be 729. Okay. So now I'm going to get a calculator, see if I can find one. Here's one. And good. So I want to see what 9 to the 6th is. 9 to the 6th. 531,441. Now I'm going to try 3 to the 6th. 729. Okay. So that's the common mistake that's made. So don't feel bad that you did it. A lot of people want to multiply these things, these numbers, and then add the exponents, but it's not that way. All you do is add the exponents. Okay. So that's the right answer. You don't have to multiply the terms. You're multiplying the terms by when you add the exponents. Okay. That's a very common mistake. So don't feel bad. All right. Let's look at another property of exponents. And then I'll give you a break here. Okay, so back to the conceptual idea here. So what if we have something like this? 2x cubed. So that's equal to 2x times 2x times 2x. Okay, so let's see what we got. 2, 4, 8. So that's how many 2's? 2 to the what? The cube, good. And x to the third, good. 8x to the third. Now look at this. Notice that if we move that inside there, okay, I don't like to use the word distribute because distribution is different. 2 to the third, x to the third. Okay, to the third, x to the third. So the property, ooh, I left just enough room here. The property would say a to the m times a to the n equals a to the m times n. Or ab to the n equals a to the n b to the n. All right. So if you like that property, that's what it is. And we'll do some with number 2 because that one's kind of, toss that one in there. So let's try some out before we go on a break here. So let's say we have 3x to the 4th. That's going to be the same as 3 to what power? And x to the 4th. Good. Now I should figure that out. I can't figure out x to the 4th, but I can figure out 3 to the 4th. Alright, so I'd go to my calculator. Or you can do this in Desmos too, by the way. 3 to the 4th. Now if you don't know how to find the to the key, okay, it's either going to look like this. So you're either going to have a calculator that's going to have this button, okay, or a calculator that's going to have this button. You might have a calculator that's going to have this button. All right, it kind of depends on what you got, okay. And let's see here. I have to just do this. There it is. In here, you're going to use, see, 3. There's a little a to the b thing, a to the b, 4, and it tells you what it is. Okay. So if you're going to use Desmos, you just go 3 to the, and then 4, whatever number you want. So that one's done. Okay. Let's do one more. X to the 2nd to the 3rd. This is a pretty good example conceptually of property number 2 there. So this means I would have x to the 2nd, x to the 2nd, x to the 2nd 3 times that 3, which means I'm going to have 2, 4, 6 x's. Okay. So if I have x to the 3rd to the 4th, again, don't write these down. Okay, just kind of watch because it's kind of tedious to write down. How many x's are we going to have? 4. But don't forget each one of them is 3. 12. So what do we do with these numbers to get our final answer here? Multiply them. Yeah. And that's what this property here says. Okay. You're going to multiply them. So we're going to use these properties of exponents to help us out on the multiplication of polynomials. Alright? That's why they introduce it. But there is a little section in there where they talk about those, using those properties. Okay? Questions on that part? Don't forget to ask questions. Alright, well, go take a little break. Okay, so one other thing on the exponents, sometimes this becomes a problem where we have the difference between what this one says and what this one says, particularly with a calculator. Although it doesn't seem like it's been as big an issue as it used to be. So, for example, I'm going to try mine out and see what it does. Okay, so I'm going to go to negative to the, oops, I didn't want, oh yeah, to the fourth, and it says 16. Okay, which is the correct answer for this one. Okay, this one though is actually negative 16. So you want to make sure you see a difference between this and this, because conceptually, oops, this means we're going to take negative 2 4 times which is a positive 16, because a negative times a negative times a negative times negative makes a positive. Whereas this one says we're going to take 2 to get 16 and then make the final answer negative. So be careful on that. When you're doing these problems, I was just kind of looking at them. All right, they have the power, the exponent, on the outside the parentheses. So you want to treat it more like this. Okay. But if you ever run into something like this, this would be more what you would see probably in an order of operations problem. But I want to make sure you kind of see that. You probably saw that in Math 60, I would think. Whoever taught that went over it with you. Okay, so back to what we were doing. Okay, so let's do some, again, I would just simply call this simplifying, because that's pretty much what it is. Okay, they call it find each product of the monomial and the polynomial. Find each product. That's what they're asking you to do. Okay, so let's start off with a one that looks like this. Okay, so this would be considered a monomial and a binomial, but you're just going to simplify them. The idea here is you just want to distribute this inside. Again, this is probably something that you did in Math 60, so that'd be 4x squared plus 20x. All right. You can't combine those because the terms are not like, so that problem's done. All you're doing is just distributing that inside. And they don't have to be x's, for example, like this one. It will be, we'll make this one a little bit harder. Okay, so we're just going to distribute this inside. Negative 5y to the third minus 15y. Again, you can't combine those because they're not like terms. Okay. So all we're doing here is distributing. And we're using those properties of exponents here. Doesn't seem like it, but you are. 3x. 1, 2 is 3 plus 6x squared plus 24x. Okay, so that's all we're doing. All right, it's just distributing inside. Any questions on that part? Okay, so believe it or not, that's the end of 5.2. .3 is more multiplication of polynomials. This is what you're going to see most often. Okay? So, I'm just going to write one out. Alright, so we're going to multiply these two polynomials. Okay? This is a very common thing to do in mathematics anyway. It's particularly algebra. To multiply these, we're going to use something called FOIL. Alright, it's even called FOIL in your book. It's been used, the term has been used for years. You probably did it when you were in your younger years. Okay? So, basically what FOIL stands for is first times first. So we're going to multiply these two x's here. First times outside, inners, inside times last. Alright? But really all you're doing is just double distributing. So you're just taking this x and multiplying it by both of these, and this 3 and multiplying by both of these. You're just double distributing, that's all that really is. So if we multiply, x times x gives me x squared. X times 4 gives me 4x. 3 times x gives me 3x. 3 times 4 gives me 12. Now almost every single time the stuff inside gets combined. 4 and 3 gives me 7. Oops. And that's done. Okay. That's called foiling. So there's even some problems in 5.2 that ask you to FOIL, but they don't introduce it to 5.3. Alright. Foiling is something you'll get very, very good at, and it usually doesn't cause too many problems for most people. Okay, so you'll be fine with it. So again, here we're going to FOIL. First times first, first times last, outside, innards, inside times last. X squared plus 6x minus 5x minus 30. Inside stuff always combines. Rare that it doesn't. Okay. More foiling. We'll beef it up a little bit. Throw some y's in here. Okay, again, FOIL. 12y squared minus 24y plus 20y minus 40. Again, I'm going to combine the stuff inside. Oops. You know, again, slow down, be careful, make sure that you're reading what that says. You got a negative 24 plus 4. It's going to combine and give you a negative 4. But all we're doing is double distributing. And it doesn't matter what the situation is, that's all you're going to do. I'm going to multiply this, 2x to the 4th minus 8x squared minus 6x squared 24. Combine the stuff in the middle. I'll give you an example where stuff in the middle doesn't combine. Okay? That's all there is to foiling. You just double distributing. You're multiplying. Using the properties of exponents, you don't really know it because it makes sense to you. Let me give you one where maybe I better make that one a 3x squared plus 2. There's no way this is going to combine, so we'll multiply this. So we're multiplying, so it's going to be x to the 5th. Okay, because we're just going to add the exponents. 2x to the 3rd. Oh, once you know what it combines. Gosh dang it. Maybe if I just make that an x. Ah, they won't combine. There we go. Okay, now the stuff in the middle doesn't combine at all. Alright. So as long as none of those powers are the same, you can't combine it, and that's okay. I don't know if you'll see one like that, but there's an example of it. And that's foiling. The other one kind of problems you'll see, and again, it's not that different than what we just did. You're going to see something written to a power like 2, but if you understand that that means this. So what I say, I always tell students, if you see x plus 3 or anything to the second power, write it twice, because that's what that means. Taking something to the second power, you just multiply it. It's repeated multiplication. Now that you've written it twice, you FOIL it. Okay. So if you see anything to the second power, write it twice. You just FOIL it. All right. That's all you gotta do. Questions on that part? A little bit easier in graphing, huh?
So, I guess the question, when you had that question on x squared, you said it combined in center?
This one here.
Yeah.
This one doesn't combine. I made it x squared, yeah, because then I had two students who were going to combine. So I had to do this stuff. Was it this one? Was this one the x squared?
Yeah.
So x times x squared gives me x to the third. So that would be x to the third. And that's why I had to change it.
Because it's x to the 1 or whatever.
Right. Okay, so let's do this then. So I want to give you some problems to work on off your assignment, and for about 20 minutes or so we'll go over them. See where we are here. Take our quiz for the night, and then we will be done. So let me find some that